Hello. Hello. So let's today we are going to discuss one experiment of the single phase transformer, means open circuit and short circuit test. Okay. So just try to describe why we are going to perform this experiment and what we can find out through this experiment. Okay. So just try to see the overview of this experiment. First of all, just whenever we are going to perform these two tests, that means open circuit and short circuit test of the single phase transformer. So can we are able to find out the total parameters of the equivalent circuit of the transformer. See? Not. That means core loss resistance RC, magnetizing reactance XM, and primary coil, that means LV side resistance and HV side resistance and reactance on both sides. Okay. And one thing, if we perform these two tests, then we are also able to find the efficiency of the transformer. Okay. So as we know that the analysis of any electrical device, we require to parameters of that device. That means the resistance, reactance value. Okay. So we can analyze that device for their characteristic of various. Okay. So just try to share the screen and we will tell you. So we are going to perform this test with the virtual lab. So we will find out here the determination of transformer equivalent circuit from the open circuit and short circuit test. So some parameters we can find out with the open circuit and some parameters we can find out with the short circuit test. Okay. So you have to, before that you have to know the basic concept about the transformer and their measuring instrument. Okay, so one by one we can just try to proceed here. First. So our aim is determination of why we are going to perform this test. That means determination. Our aim of this experiment is the determination of transformer equivalent circuit parameter. Okay, from the open circuit and short circuit test. So with the help of open circuit, if we perform the open circuit, then we are able to find the core loss resistance. That means RC and magnetizing reactance. That means XM. Okay. During this test, the open circuit test, whatever the power may be consumed by the transformer, that we consider as the core loss. Okay. And during the short circuit test, we can find out the equivalent resistance of equivalent leakage reactance of the transformer referred to the high voltage side. Okay. So you have to concern when we are going to perform the open circuit test. That means which parameter, which winding we require to open and kept open, and which winding we require to connect the instrument, measuring instrument. Okay. So when we are going to discuss about the first one, we are going to discuss open circuit. So during the open circuit, okay, we kept the high voltage side open and low voltage side supply given, and all the instrument connected across this device. That means through the towards the low voltage side. Okay, that means one voltmeter we require to connect, one ammeter, okay, and one wattmeter for their voltage, current, and power measurement respectively. Okay. So just try to see what is the theory part of this open circuit test. Okay, without circuit. So you find out, I think you have the basic knowledge of the transformer. So the open circuit and short circuit test are performed for determine the parameters we already explained few minutes earlier. Okay, and their efficiency. So voltage regulation and circuit constant. Okay. So these tests are performed without the actual loading, and because of this reason, the very less power is required for the test. The open circuit and the short circuit test gives a very accurate result as compared to the full load test. Okay, when we determine the efficiency or their parameters, then we are able to get the more accurate result compared to the full load test. Okay, so what is the open circuit test? So the purpose of the open circuit test is to determine the no load current and losses of the transformer, because of which their no load parameters is determined. Okay, no load current and losses. So this test is performed on the primary winding of the transformer. That means towards the low voltage side. Okay, and the wattmeter and primary means low voltage side. The wattmeter, ammeter, and the voltage voltmeter are connected to the low voltage side. Here we can say the low voltage side instead of primary winding. Okay, so the nominal rated voltage is supplied to their primary winding with the help of the AC source. So you may be concerned whenever you are going to perform the open circuit test. That means you supply the rated voltage. Okay, and we perform the open circuit test at the rated voltage and frequency. So, okay, and the all instrument we required to connect towards the LV side. So the secondary winding of the transformer is kept open. That means high voltage side. You can say that the high voltage side kept open, and voltmeter is connected to the terminal. So this voltmeter measure the voltage across the high voltage side. Okay, so we are able to get the voltage regulation. So as the secondary of the transformer is open, the no load current flow through the primary winding. Since no so the LV side, HV side is no load connected, so no current will flow through the secondary coil, or we may say that the HV side. Okay. So whatever the current will flow during this test, that is known as the no load test, no load current. Okay. The value of no load current is very small as compared to the full load current. So you kept this point is very carefully in your mind. Okay, that means the no load current is almost about the how much 2 to 6% of the full load current. Whatever the full load current of the transformer, only required the no load for the 2 to 6% of that full load current. Okay, so the copper loss occurs only on the primary winding of the transformer, because the secondary winding is open. The reading of the wattmeter only represents the core loss and the iron loss. Okay, the core loss of the transformer is same for all the types of the load. It does not depends on the load in the family transformer. So either doesn't matter either it is full load or no load. Okay, so core losses is same for all the loaded of the transformer. So this is the circuit diagram connection for the no load test. That means we require to one transformer. Here I have the two coil or two winding. That means one is your LV winding and other is your SV winding. So we consider that this side of winding is your LV and this one is your SV. So SV kept here open, and what are the various instruments connected towards the LV side. And AC supply is given with the help of auto transformer, or maybe say that with the single variac. Okay. So movement of this auto transformer variac point just change their position. So corresponding to that, you may find out the connection of voltmeter and emitter is reverse here. So the voltmeter is connected here instead of here. Okay, and emitter is connected here instead of parallel. Okay, so you have to concern, don't confuse about this diagram about the connection of emitter and voltmeter. Okay, so voltmeter is connected across the parallel and emitter is always connected series with it. Okay, so and the next one is our wattmeter. That means for measurement of power during the no load test. So you will find out here four terminals of the wattmeter. One is your N, L, and C and B. Okay, so this one, that means ML coil is known as the current coil. Okay, have the low resistance compared to this VC, or maybe this one is called as pressure coil or potential coil. Okay, pressure coil PC. So you may be denote this coil short, that means a CC, and PC, that means pressure coil. Okay, so L and C is common, and V is connected again to the negative of the LV winding. Okay, and again come back to the supply. Okay, so this is the connection all about of the no load test. Okay, so when the voltmeter indicate the rated value of the LV side of the transformer, you just stop the movement of the variac. Okay, and at that instant you have to note down all the reading of the instrument. That means wattmeter, voltmeter, and ammeter. So that you have to note down. Okay, and then we are able to find the parameters of the core loss component, that is core loss resistance and magnetizing reactance. Just try to see here the calculation how we can find out. We already note down the power, voltage, and current. Okay, so with this data we can find out the RC and XM, that means core loss resistance and magnetizing reactance. Okay, so calculation you may be indicated there, that means W0, that means wattmeter reading, and V1 is your voltmeter reading, and I0 is ammeter reading. So then the iron loss of the transformer we can write here, that means Pi equal to W0 is wattmeter. What is the reading of the wattmeter? That is indicated by the core loss. Okay, that is core loss or iron loss. When we say that, so that is equal to nothing but voltage into current into power factor, no load power factor. So VI cos phi. Okay, VI cos phi. So concerned about this point. So that means power equal to VI cos phi. So maybe wattmeter reading, that is put here, and voltmeter and current reading put here. So you are able to find out the no load power factor, that means cos phi or cos phi 0. Okay, so if you are able to get the no load power factor, that is cos phi 0. Okay, so then you are also able to find the sin phi 0, since you are know the value of cos phi 0, that means sin phi equal to sin phi 0 equal to square root of 1 minus cos square phi. So from that we can find the core loss current, that means IC and IM. Okay, so IC or IM may be written as here by the IW instead of IC. Okay, so maybe say that the IC equal to nothing but this no load current indicated through the emitter. That means we say that the I exciting current, that is I suffix E. So I suffix E, if we takes the component along the supply voltage, so that may be written as the I cos phi 0, cos phi 0. Similarly, we can find out the component of magnetizing current. That means I m equal to I e into sin phi 0. Okay. So if we are got the value of core loss current and core loss magnetizing current component from this no load current, that means IE, then we are able to find the value of core loss resistance and magnetizing reactance. That means RC and IM. So we may put here the value of RC equal to, that means supply voltage V1 at the no load, divided by IC, or maybe written here IW, whatever, if you put the value of V1 and IW. Okay. So similarly, the magnetizing reactance is represented here, that is X0. Okay. That means V1 by IM. So you got the value of V1 by IM. Okay. This V1 you maybe find the value with the help of voltmeter. So put the value of V1 and IM, magnetizing current. Okay. Then you are able to get the value of R0 and X0. So in this way, you can observe these two parameters with the help of open circuit, is not? So next, we try to uh, discuss about the short circuit. Okay, so you have to concern about the joint, how we can proceed, how we can connect the instrument, and why we connect the LV side and kept open HV side. Okay, because you are not able to get the actual measuring device measurement, that means voltmeter emitter, in a standard voltmeter emitter reading for the, if you connect the instrument towards the HV side. Okay, so this maybe explain with the more clearly with the one example. If you consider, that means suppose that 3300 volt by 230 volt transformer. Okay, so if 3300 volt by 230 volt transformer, if you perform this open circuit towards the HV side and kept the LV side open, then you may not be able to get the rated voltage of this 3300 volt. Uh, okay, in the standard measuring instrument. So you have to concern about this point. Okay, that's why we are, if we connect all the instrument, that means towards the LV side, then you may find out 230 volt and 400 volt, 400 volt, 400 volt. Okay, so maybe find out these two test open circuit test on the LV side and kept the HV side open. Okay, so you have to concern about this point. And next we are going to discuss about the, so at the, that means if you flash, so you maybe get the their 20 kVA transformers with that 20 kVA transformer. Okay. So your current rating at the LV side, that means 20,000 divided by 230. Okay. So maybe get the value you find out from this data, LV side and HV side current value. Okay. Next, we are going to discuss about the short circuit test. Okay. So first point you have to keep in your mind, these tests, that means this is a short circuit test we perform on the HV side and short the LV winding. Okay, because we are going to perform the short circuit test at the rated current and rated frequency. This point is very important. Okay, short circuit test is performed at the rated current and rated frequency. Okay, and next, whatever the instrument we require to connect that connector towards the HV side of the winding and LV winding sorted. Okay, so as you know that the we can observe through this test, that means copper loss. Okay, or we say that the ohmic loss at the, on the full load. Okay, so and other parameter we can find out. So the copper loss is used for finding the efficiency of the transformer, and the equivalent resistance, impedance, and leakage reactance are known by the short circuit test. So these 2 points you always kept in your mind. Okay. That means so where we perform the short circuit test and where we perform, that means LV side or SP side, which winding we require to sort it, and which winding we require to put the measuring instrument. Okay. So you may find out why we for the open circuit. Maybe concerned about this loss, that means 2 to 12% of the rated voltage is required to flow the rated current in the winding. Okay, so we just try to connect towards the AHP side. So suppose that we consider that 3300 volt of by 230 volt of a transformer. So what is the 2 to 12% of this voltage? That means 3300 volt. We get the value of, that means 66 to how much? 33 into 12. Okay. So almost you will get in the standard range. That means about the 400 volt or something like that. So this type of voltmeter and wattmeter rating you will find out in the standard measuring instrument. Okay. That's why we are going to concern about the connection of the measuring instrument towards the high voltage side. Okay. So can say in a simple way, that means this test performed at the rated current. So for the rated current flow in the winding of the transformer, we required only the 2 to 12% of the voltage. Okay. So you may find out here the explanation, and their circuit diagram is similarly same as you may be only concerned about the winding. Okay, that means whatever is instrument connected towards the HV winding instead of LV winding in open circuit. Okay, and this LV winding is shorted. Okay, so this is connection about for the short circuit test. That means a wattmeter, voltmeter, and ammeter are connected to the high voltage winding of the transformer. Their primary winding is short circuited by the help of thick strip or emitter. We connect the emitter which is connected to their terminal. So the low voltage source is connected across the secondary winding because of the is the full load current of flow from both the secondary and the primary winding of the transformer. The full load current is measured by the emitter connected across their secondary winding. The low voltage source is applied across the secondary winding, which is approximately 5 to, we will say, explain in few minutes earlier all these things. That means 5 to 10% of the normal rated voltage required for the rated current flow in the transformer, 2 to 12% or 5 to 10 in this range of the voltage. Okay. So the flux is set up in the core of the transformer. The magnitude of the flux is small as compared to the normal Capacitance flux. So the iron loss of the transformer depends on the flux. So it is less occur in the short circuit test because of the low value of the flux. So reading of the wattmeter only consider the copper loss during the short circuit test. Okay, and the voltmeter measure the voltage applied to their high voltage winding and the secondary current induced in the transformer because of the applied voltage. Okay, so this is all about the connection during this short circuit test. Okay, so we'll find out here their calculation. That means what is it? Okay, so what will this one WC represent the wattmeter reading, and V short circuit, that means voltmeter reading, and I short circuit ammeter reading. Okay, so you have to note down at the rated current all the reading of the instrument. So power loss, that means copper loss, equal to, we can write here how much that means this value I short circuit square into RS equal to, that means wattmeter reading. Okay. So with this help, we can find out, that means RS. Okay. That means WC divided by I short circuit square. So if you calculate this value RC, if you put the wattmeter reading and ammeter reading in this equation, okay. Next we just find out the equivalent impedance referred to the HV side. Okay. So impedance can be written as the voltage by current. Okay. So V short circuit was supply voltage divided by short circuit current. Okay. So you get the value of resistance and impedance. Okay. Resistance and impedance. So we can able to find out the reactance value. Okay. How we can find out the reactance value? The reactance value is nothing but we can find with these two value, that means impedance and resistance. That means reactance equal to square root of how much? X equivalent on the high voltage side is equal to square root of impedance value on the equivalent impedance on the high voltage side square minus resistance of the equivalent resistance of the high voltage side square, is not. So put the value of impedance, equivalent impedance and resistance value in this equation, then you are able to get the value of reactance value on the high voltage side. Okay. So these two data can be find with the help of short circuit test. Okay. So now if you want to find the R1 and R2 and X1 and X2, so that is equal to half of the R1 equal to R2 equal to half of the R equivalent on the HP side. Okay. Similarly, X1 and X2 equal to half of the XE equivalent. Okay. The high voltage side. So you are may be able to then convert this value towards the high voltage side. So since this resistance you are able to get in the high voltage side may be transferred towards the low voltage side. Okay. So you may know that the how we can transfer the reactance value and resistance value towards the high voltage side to low voltage side. So from that formula you can apply here and just calculate the value in the low voltage side. Okay. So we are calculate the equivalent resistance toward the high voltage side here by this formula. Okay. So this is all about the short circuit test. So you have to concern how we can perform this test and how we can note down their voltmeter, ammeter, and wattmeter reading, and just put on their standard formula. So we are able to get their value of resistance and reactance value on the high voltage side. You know, so maybe get the corrected value. So this is all about these two taste of the transformer. Okay. So I think it's clear to all of you. So this is all about you have to concern how we can perform these two tests, open circuit test and short circuit test, and which parameter we can find out by which test. Okay. And just a calculation, some basic calculation here with the help of reading of voltmeter, ammeter, and wattmeter reading. You have to note down during the open circuit test and short circuit test. Okay. So maybe next we can move towards the next point. That means pre-test. So before the test, you have to require this knowledge. Okay. So you may find out some question here. That means before we are going to perform this test on the simulation. So transformer with high leakage impedance is used in. You have to give in some option here. That means ABCD, form of ABCD. So you will go through this question before the performance of test. Okay. So the next question is given to you. If the per unit leakage impedance for the primary of transformer is X on the given rated base value, if the voltage and volt ampere are half, then change the per unit impedance will be how much? So I think you may be familiar with the per unit value, how we can express any quantity, electrical quantity in per unit. That means base value by some actual value. Okay, so that is per unit value. Okay. So we will convert this value in some particular base MVA and volt ampere rating page. So just if half, then you have to convert this value how much this X. Okay. So you maybe know that I think the formula. Okay. So the new volt, that means we can put on this formula. That means if you want to find the impedance, that means Z impedance can be represented in per unit for the new. That means equal to kVA new by kVA old into kilovolt old whole square by kilovolt new. Okay, kilovolt new whole square. So new is how much? Half. Before you suppose that A, and now half value is your A by 2. So put on this formula, then you just got the value of this one. Okay. And similarly, you maybe get the value of voltage regulation for the transformer. So that much the voltage regulation of the transformer. That means how much? This is nothing but change in the secondary from the rated voltage to full load with respect to uh, full load voltage. That means this option you have to choose A. That means E2 minus V2 by E2. Okay, with respect to no load voltage. So basic problem you will find out here that you require to solve here. That means okay. So you will find out the 3 winding instead of 2 winding transformer is to be used as an auto transformer. So this is the part of the auto transformer. Okay. So you will practice some problem here. Which type given here. Okay. So next, what is the procedure for perform this experiment? Okay. What is the procedure for perform this experiment? That means required to. So first of all, just you have to consider what is a requirement for perform this experiment. Okay. So you find out here, that means some instrument. That means what we required here. Whatever I have so explained in the circuit diagram, that instrument you required here. Okay. So you will find out one single phase transformer is this one. Okay. One voltmeter, one ammeter, and one wattmeter. I already shown in the circuit diagram, and how we connect just explain to this one. Okay. And one auto transformer, single phase auto transformer, you may find out here. And this is your MCB, that means your power. If you put here, that means in the upside, then it will be at on position. Okay, so from this point we just power given to the auto transformer, that means from polarity of this MCB is connected to the positive polarity of the auto transformer, and negative of this MCB is connected to the negative of the auto transformer, and from this point we connect the uh, one voltmeter for the measurement of voltage. Okay, so just connect a voltmeter, this voltmeter in parallel with the supply. That means positive of this auto transformer is connected to the positive of the voltmeter, and negative of this auto transformer is connected to the negative of this voltmeter. So we are able to observe the reading here from the voltmeter. And next, we connect ammeter, okay, and wattmeter. So just you have to concern the connection about how we can connect the ammeter and wattmeter. So from this point, positive polarity of this one is go to where? That means positive polarity of the emitter. Okay, and from the negative terminal of this emitter is goes to the M of the wattmeter, M terminal of the wattmeter. Okay, and you will find out L and C is common in the circuit diagram also. So just connect L and C with the one wire, and that will in short circuit. Okay, short circuit this L and C, and from uh, this L point of the wattmeter goes to the positive of the LV winding, that means here, okay. And from the V terminal of this wattmeter it goes to the negative of the LV winding, and again from this point go back to the auto transformer. Okay, so if we connect here one voltmeter in HV side, so you will get the voltage, whatever the voltage induced. Okay, and if your connection is correct, then you will be click here, that means on check connection. If it will be right, then it will be show to yes, your connection is correct, you can move for the experiment. Okay, otherwise if your connection is wrong, then you maybe reset from this point and again try to connect the instrument in proper manner. Okay, and if you had to click the table, then you will get the data at the no load value, that means at the wattmeter reading and emitter reading, and this one is your voltmeter reading at the no load test. Okay, so in this way we just try to simulate and perform this after one by one. Okay, so you have to concern about their procedure. So maybe write down this one. They make the proper connection by clicking the node as instructed below. If the wire is misplaced, click the node number to detach the node wire. Okay, and the second step is for your, then click check button to check the connection is correct or not. Okay, and the click auto transformer to get the change in our meter, and then that means reflection in the voltmeter, ammeter, and wattmeter. And fourth step is your the click add to table. We explained a few minutes earlier the procedure. So whatever I explained, that will be written here in a step by step. Okay, so we go through this one one by one. Okay, that means fourth point. Then click add to table button to get the reading of our open circuit transformer. Then we have done open circuit transformer test. Then click short button for short circuit transformer test. And then last one is you make the proper connection by clicking the node as instructed below. So if the wire is misplaced, then click the node number to the detach. Okay, detach. And 7 number is the click then click check button to check the connection is correct or not, and then click add to table button to get the reading of the for this one is connection for the short circuit. Okay, so just try to explain here whatever the, so same things is required. We already explained in the few minutes earlier. So they are concerned about the connection of the instrument and which winding we require to sort. Okay, so I already mentioned that in few minutes earlier, in all the instrument we require to connect during the short circuit test on the LV winding and sorted the HV winding. Okay, so this one is considered as HV winding. You are in P2. This one is LV winding. So this LV winding is sorted. Okay, and connection diagram is the same. Instead of open circuit, so just maybe power given to this auto transformer from here to here, and from here again for the measurement purpose one voltmeter is connected. So this voltmeter connected in parallel with the auto transformer, and one ammeter you require to connect. Okay, so this L and C may be short circuited. Okay, and power is given from this auto transformer to the ammeter. That means positive terminal. Okay, then from the negative of this polarity may be given to the M of the wattmeter, and from V come back to this HV winding negative polarity. Okay, and from this point we will connect at the negative polarity of the auto transformer. Okay, so this procedure you have to come, and if your connection is correct, then you will be click here. Okay, and then add to the button. So we will get the reading, that means wattmeter reading, power short circuit. Okay, and emitter reading I short circuit and voltmeter reading short circuit volt we are doing the short circuit. Okay, if you submit, then you will get the final value of. Okay, so just we stop here, and in the next class we will just try to perform this experiment. Okay.